Alright, now let's start with a new concept. Say for example, a list is given to you, minus 3, 7, 8 and minus 8. I want to create a list with only the absolute value of these elements. So there is a built-in function that is called abs. Okay, if I write absolute value of x, okay, in MATLAB when you work, this function will run on each of the elements one by one, and it will return a list with the absolute value. But if you try to do the same in Python, it will not work because the vectorization approach does not work in Python in this way. So you have to do it one by one using a for loop. That's the normal approach. So one thing that you can do is use a for loop, go one by one to try to perform this operation. Okay, so let's take a look at it on a spider. Say for example, okay, so this is our x, this is a list of things like that. So what I am trying to do, I have to perform this absolute operation. Okay, as you can see, this operation and this function does not run on a list. It runs on a particular item like this way, absolute value of minus 8. Okay. So one solution is that you can use a for loop, iterate through one by one, and return take out the absolute value, perform this operation, and save those things in a new array, new list. Okay, so that's one approach. You can also perform this task using the numpy array. Okay, that was already described in one of the lectures. So using the numpy array. Now one other thing that was taught was that is called list comprehension. Okay, list comprehension. Okay, that's the shortcut way to do this thing. It can be done very easily if you try to take a look. Out is equals to what I'm going to write, fs of I, that is the iterator variable for I in our list, that is x. As you can see, this out is returning the absolute values of the elements. Okay, so this is three way, but there is one much more efficient way to do that, that is called map. Okay, so what is a map? So map is a function, a built-in function in Python. It takes two arguments. The first argument is a function. Okay, the second argument is a list, or is a list, or you can say any sequence. It can be a string as well, like this, any sequence. So this map function takes a function and performs that function on each of the elements, individual elements on our list, on our sequence. Okay, so that means that if I write like this way, say for example, write map, this apps is our function and x was our list. If I run this function, okay, if I run this code, what will happen that this function absolute f's will be run on each of the elements of our x. So if I come back here and try to do it, let's do this f's and on our x, so this is going to return a map object. To get the output, I have to convert it to a list. Okay, to see the output, let's do this. So as you can see, now I can get the outputs like this way. So in this way you can actually, this is the other ways you can actually perform this operation, that something that you could do directly in MATLAB. You can use this map function to run a function on each of the elements in a sequence. This is similar to the array_fun. If you remember from your MATLAB, array_fun or cell_fun was two functions that was introduced, or BSX_fun. So these functions used to perform the operation, the function on each of the elements. So similar to map, it performs this function on each of the elements of our sequence. Okay, so I hope you got the idea. Now one thing, so this function that I'm talking about, this function can be a built-in function like these apps. Okay, we can also try something like this from your exercise. Okay, this map, okay, there was a function that was ord that provides the ASCII value of characters. Say for example, if I write some characters like this, IOP, Now as you can see, it is returning the ASCII values of each of the elements. Okay, you couldn't do it directly. If you try like this is going to generate an error. Okay, it takes only one argument. So this way you can perform this operation. You can also use list comprehension, that's completely fine. Now one other thing, that is here in the function you can use a built-in function like this. You can also use a user-defined function. You can also use a lambda function. Okay, this kinds of function that was introduced in your previous two lectures. Okay, you can use any kind of function in here. Okay, say for example we want to do something. Instead of returning the absolute values, we want to return true or false. Here we want to return true or false whether this is greater than 0 or not. Okay, so positive elements or negative elements like this. So if you remember, if I do directly like this, x is greater than 0 in a numpy array, you could do it directly. Okay, but that will not work in Python's list. So we can do something like this using the lambda function. If we come here, list of map of, I will create a function, lambda function. Instead of writing a function in details like this, I can simply one expression function. Lambda is the most efficient way to do that. Lambda, what I'm going to place? I'm going to place the iterator. What I'm going to check? This iterator is going to take each element one at a time. And what I want to do? I want to check whether it is greater than 0 or not. A conditional statement. Okay. So if I is greater than 0, it will return a true. If not, it is going to return a false, like this. And the last one is the sequence. Our sequence is x. Okay, let's do this. And as you can see, false, true, true, and false. It is returning like this way. Okay, so when you're working with map, you can also use this lambda function like this way. Now let's take a look at another example here. Okay, this is exercise 1. So I am putting this exercise so that you can get familiar with how to solve problems in Python. Okay, this was an exercise that we already did in MATLAB. Okay, I'm providing the same exercise so that you can relate very easily. So the question was, find all the divisors of a given number. Okay, so a number is given like 100. You have to find the divisors of the number. So these are the divisors. You have to return them in a list. Okay, so the process is very simple. We want to do this using a user-defined function. Okay, now say for example, let's create a function def. Okay, so this is the function definition that we have provided. Now what I want to do here in the function body, I want to perform some operations. What I want to do, I want to create a list first, an empty list. Okay, so I have created an empty list. So what I am going to do, I am going to check, I am going to loop through from 1 to 100 and check whether each and every one of them divides this number, okay, without any kind of remainder. That's the divisor. Since 2, if you remember the modulo operation, that's what I am going to do. So I loop through for I. So in MATLAB we used to write like this way: for I is equals to 1 is to 100, something like this. But this will not work in Python. Okay. So the Pythonic way to write it, something like this, is something that is called range. If you remember, that was a function that was introduced. For I in range, start from 1, finish at 100. 100 means this n. Okay, let's write it. I'm creating this function so that I can use it for any kind of input variables. But one thing here is that if you remember this range, okay, let's give it here. Let's see, list of range of 4,6, 4,7. The output will be 4, 5, 6. This last portion is excluded. Okay, it is not included in the range. Okay, Python works this way, so you have to be a bit careful about these things. So I have to do something like n plus 1. That means it is going to count up to 101, and the range, it will be up to 100 when I'm calling this one. Okay, so for I in range this, what are you going to check? If n, the modulo operator is the percentile sign, n modulo I is equals to 0, Okay, what I am going to do, if it is 0, if this condition is true, if this condition is satisfied, then this I is one of the divisors. I want to append it to our list. So let's append it, out.append this I. Okay, so our task is actually done. Now I have to return something. This function has to return something. What I want to return? I want to return our final out. Okay, if you remember, when I am writing this for loop or if loop, I am not finishing it with any end command. Remember, whenever I am coming it here, that means the if is done. It is the indentation that is making everything. When I come here, the for loop is done. Okay, it is the indentation that is actually take care of the end. Okay, so let's run it. So this command is run. Let's check it. Okay, as you can see, it is returning the outputs. Okay, I can also tweak this code a little bit to make it much more efficient, but that's completely fine now. So I have this user defined function now that is called divisors, that returns the divisors of a particular number. Now let's take a look at exercise 2. What it is saying, that a list of integer is given. I have to find the factors, that means the divisors of all the elements. Now how we can do that? So that means that I have to run this function, I have to call this function on each of the elements. Okay, so one way to do that would be to create a for loop, go through each of the elements and run this thing. Okay, but much more efficient way would be, let's call it out is equals to list of map. If you remember, inside the map I will call a function. I can call user defined function as well, and the function is divisors, and this divisors is already run here, so I can use it here. Okay. I cannot use it in a new Jupyter notebook. Okay, so divisors, this is the function, and what I want to provide, the sequence is list. Okay, and I want to print out. Okay, so as you can see, this is going to provide me a list of lists. Okay, now it is much better. So as you can see, for each of the element 4, the divisors are 1, 2 and 4. For 12, the divisors are this. Okay, a list of list is provided here. Okay, so I hope you got the idea. So using this map, okay, this map operation, you can call a function on each of the elements individually like this way. Okay, so this is one other efficient way to do it. Okay, this kind of operation. Okay, so 4 is map.